Hello, welcome back to a new video. So you have just been introduced to the formal definition of a vector space and the 8 vector space axioms. But at first glance, these axioms may seem a bit random as it is not immediately clear why we will want these 8 properties, or where does the notion of vector space even come from in the first place. Because vector spaces are the fundamental object of study in linear algebra, to understand where vector spaces come from, we must look at how the modern theory of linear algebra became what it is today. So the name of the subject, linear algebra, is in fact incredibly descriptive because one can see what the subject is about simply by examining the name. So the first word is linear. So a function f is linear if it satisfies two properties, f of x plus y equals f of x plus f of y, and if you multiply x by some constant c, then you should be able to pull that constant c to the front. You get f of c times f of x. So just by looking at the word linear, we can see why we want to define vector addition and scalar multiplication on our vector spaces, because you need those two operations to be able to study linearity or to even define linearity in the first place. But the word that really captures the essence of linear algebra, the essence of vector spaces, is the word algebra. So before taking a look at linear algebra, let's first take a look at the algebra you already know. Algebra like 2x plus 3x equals 5x. And where does this even come from? So algebra is essentially the generalization of arithmetic, and arithmetic is things like, so you have two triangles plus three triangles, you get five triangles, right? And you can do this with things other than triangles. Say you can have two rectangles plus three rectangles, you get five rectangles, right? So immediately you observe that rectangles and triangles share some properties. And because it is these properties that we want to study, for our purposes, triangles and rectangles and other things that have these properties, like apples and oranges, are simply the same thing, are essentially the same thing. So we can extract these properties and abstract things like triangles and rectangles and give them the same name. In this case, we usually choose the letter X. And the advantages of doing so is that instead of solving problems about triangles and rectangles like we did over here one by one, we can solve all problems of this form simply by making some general statement about X, about this abstract entity X. So in this case, the general statement is 3x plus 2x plus 3x equals 5x, right? So by making this general statement, we've essentially solved problems of the form 2 of something plus 3 of something, you get 5 of something, right? It doesn't actually matter what that something is. All that matters is that something have these properties that triangles and rectangles have, so that we can apply this general statement. And this is essentially what linear algebra does. But instead of abstracting arithmetic and things like triangles and rectangles, it abstracts the concepts of linearity and things that exhibit the properties of linearity, like arrows, or if you have lists of numbers, or you have functions And these objects all share some properties. They all have a linear structure. So for the purpose of linear algebra, these are essentially the same thing. So we can do the same thing like we did with rectangles and triangles. We can abstract these things and extract the properties that give them the linear structure, namely the vector space axioms, and give them the same name, which is vectors. So by doing so, we can make some general statement about vectors that can apply to all things that satisfy the vector space axioms. And this is why we study linear algebra. So the power of linear algebra lies in its ability to generalize through the notion of vector space. And it turns out a lot of things in nature and real life have this linear structure. Things in probability, in physics, in finance. And that's why linear algebra is so useful. That's why linear algebra has so much application. However, the generality and this usefulness of linear algebra comes at a price. And that price is the abstractness of the subject, which makes it more difficult to learn. So I hope in this video that I have helped a little bit, helped to understand where the notion of vector space even come from and why such a notion is useful. So thank you for watching, and I'll see you in the next video.